This is video number 2 in a 3-video series, all trying to explain the El Nino and La Nina effect and why it messes with our weather, not just here in the United States, but indeed messes with the weather globally. So this is video number 2. If you haven't seen number 1 on global winds, go back and watch that one first, because I'll be using a lot of those terms in this video. This video, however, is going to deal specifically with the jet stream. What is the jet stream and how is it formed? So we talked earlier in the last video about the global circulation of wind as it rises and sinks coming around the globe. So if I hook up my pattern again, so you can see, so here we have the globe, and here we have this rising air sinking. This is the global pattern. I'm going to spin it over here. There we go. Okay. Sorry, rest of the world, but because I'm in the United States, I'm going to focus on this. All right, so here we go. So what happens is, as we have this rising air, what we end up with in 2 different areas, right here and right here, we end up with a patch. As these winds converge, it produces right here a stream of air that is traveling toward the east, right along that area where these winds are converging together. That little clump of air, it's called the subtropical jet. The subtropical jet. And that's going to be somewhat important when we start dealing with El Nino and La Nina. Up here, we also have another one. This one is called the polar jet, or simply the jet stream. This one I referenced as I was talking about the polar vortex in one of my videos. You can go back and watch that one. I referenced the jet stream and talk about its boundary and how it gets forced north and south depending upon what kind of global temperatures we're having and what's happening with that. So we talk about the polar vortex. Go check out that video. So we have the jet stream. It's up in this area, and down here is where we have the subpolar. So we have the subtropical jet, and we have the polar jet. Those two. These jet streams are basically exceedingly fast streams of air. We're talking, they're traveling in excess, oftentimes above 200 miles an hour. On average, they're right around 100 miles. They're really, really fast. Matter of fact, jet airliners, when they're traveling the world, if they can do it, they would love to get up in some of these jet streams. If they're flying toward the east, they want to get up in those jet streams because those jet streams push them so much faster. And if you're traveling to the west, you want to avoid them. You want to get out of those jet streams because it's like trying to run into a headwind. It's going to mess with you and mess up your gas mileage if you're driving, and it's just horrible. So, all right, but these things are traveling to the east, and they're traveling exceedingly fast. And they are way up above right at what's called the tropopause. The tropopause is the space. It's the transition from the troposphere, this lower part of the atmosphere, to the stratosphere, which is the next layer of atmosphere. That's where these 2 jet streams are located. This one's going to be higher than that one because the atmosphere around the equators is going to be a little bit thicker than the atmosphere up by the poles. That's really not important. But these streams are created, and they're not fixed in position. Depending upon the weather, or depending on the time of year, those streams are going to begin to fluctuate. They're going to begin to move. So here we have the United States. As the jet stream comes across, it's normally up here somewhere around 50 to 60 north latitude. And as it comes across, it streams in. But it's going to curve. It's going to fluctuate as it comes. It's not going to be just a linear flow. Sometimes that happens. That produces a different set of kind of weather conditions. But more often than not, it's this linear flow, or it's this curved flow. When the conditions are right, like in the summertime, that jet stream is forced further north, and so it doesn't have a tremendous amount of effect on the weather here in the United States. In the wintertime, however, that comes down a little bit further, and it has more of an effect. You see, low pressure systems, the weather systems that come across the United States, actually track along that jet stream. That jet stream is almost like a path that helps to steer and curve those low pressure systems as they move across the United States. So if our jet stream, as it comes in, if it dips way down here to the south and then curves back up, then those low pressure systems are going to be most intense. On that up curve, we're going to have tremendous, tremendous amounts of storms, right? In the part in the middle, we're going to have a area of really, really cold air. And on this side, pushing in that way, we're going to have an area of high pressure, fairly warm and dry. So think about that just for a second. As this curves down and curves back up, notice it makes kind of a ridge right here and a trough right there. When we talk about a ridge of high pressure, it's talking about the high pressure that would sit in this area underneath that crest of the jet stream. As it dips right here and curves back up, now we're talking about that trough, and this is where the low pressure bad weather is going to occur. Typically, as this trough curves back up, it's along that leading edge of that trough, we tend to have a lot of severe weather. So the jet stream, as it's moving around across the United States or across anywhere in the Northern Hemisphere, there is a jet stream in the Southern Hemisphere too, but there's not a lot of land down there, so it doesn't have the same amount of impact. But in the Northern Hemisphere, as that jet stream is cresting and troughing, it's driving these weather systems, almost guiding it. So if it's just a little bit and it's far north, it does not have the same impact on our weather the way it would if it actually dips way down, which is what it often does in the wintertime. Matter of fact, the polar vortex is when that trough gets pushed way down and it starts to greatly increase the cold weather in the United States or other parts of the Northern Hemisphere. Again, watch my video on the polar vortex to get that. So this jet stream of air, both of these, both the subtropical jet and the polar jet, where we have the converging air, the air rising or coming together to sink around 30 latitude, north latitude. And then we have the air as it's rising back up, producing the polar jet stream, which is around 50 or 60 latitude, north latitude. Those two areas steer tremendous amounts of our weather. So with that understanding, now let's look at what El Nino is and why it affects the jet stream the way it does. And that's the next video, video number 3. I hope you'll check it out.